Hi everyone, my name is John, and today I'll be walking you through my cloud engineering project. This project aims to demonstrate an event-driven end-to-end data pipeline that automates ETL and enables multiple access points for users to query and interact with the data. The core goal of this project is in two main workflows. One is an automated ETL pipeline that ingests, processes, and stores data into an RDS database. In my case, it would be a MariaDB. And then we produce a user-facing API that allows users to request data either as JSON or CSV. This project illustrates how cloud-native tools like AWS Lambda, API Gateway, S3, SQS, and RDS can be combined to build an event-driven pipeline. I'll be breaking down each of these components, starting with the overall architecture, followed by a more detailed look at the ETL process, and finally I'll walk you through the API access points and how users can query data via both Postman and a custom Python SDK. We're using Postman in lieu of a true frontend, but we can envision how a frontend would work to request in a very similar manner. So first, let's start with the overall architecture. So this diagram shows a high-level view of the system architecture. At the very top, this is our ETL process, which relies on 8 Lambda functions, both to ingest data and to process data. So our Lambda function is called by an AWS Event Bridge scheduler that calls an API from a website called 12 Data that pulls financial stock data daily. So this data is then stored in S3 as raw JSON files, which the S3 then has an event notification that triggers an SQS message. The SQS message is a trigger for another Lambda function that loads the data into RDS, and the RDS is managed is a RDS managed MariaDB. On the other side, we have a API gateway that allows users to query the database. This is done through a one REST API, but we've abstracted it as a Python SDK and also a REST API endpoint. All of these components are connected using event-driven approaches so that each action is triggered automatically as new data flows into the system. Now that we have an overall view, let's look at the components each piece by piece. And first, let's look at the Lambda function that calls API. So the first function that we're looking at is a Lambda function that I call daily stock calls. And the purpose of this function is to call an API that from 12 Data to query financial closing stock data for the big tech companies, previously known as FANG. The trigger is an event bridge, and the destination is an AWS, Amazon S3 bucket. The way that this function was built is that requests is not part of the standard Lambda packages, so we had to upload a zipped version of requests. There is another way that we can build this with layers, and I will go into that later when we go into other Lambda functions that we've gone through. So it's a fairly simple script. What we do is we get the S3 bucket, we get the API key, which is stored in AWS secrets, and then we have a Lambda handler that calls it that receives an event trigger. So we basically looked at all I think 5 stocks at 1 intervals, and it builds the API query strings, and we basically receive the data and dump it as a JSON then into our S3 buckets. So I will run a quick test of this to show how it's done. And we can see that Fangstock data successfully loaded into S3. So we have fetch data for Meta, fetch data for Apple, Amazon, and so forth. Lastly, how we configured this is that when we look at the execution rule, we had to make sure that this had access to both S3 and our secrets, as well as when we look at the configuration environment variables, the S3 bucket is stored here, and also our API key is part of our AWS secrets. Next, we will move on to look at the S3 bucket where our SQS is stored. So when we look at our folders, it's under raw, and basically it is querying data every day and putting it into our folders. So if we look at the 17th, this was last pulled on the 16th. The reason why it's 17th is because it's in UTC time, and I believe this would be in yes, this would be in local time. So therefore it's a little bit off by 1 day. Anyways, this is the deposit of all of our data. If we look at what it looks like, we can see that the JSON data looks very similar to, we have an opening date, open, high, low, close volume, and it looks at it for the subsequent days before it. And how we created this to have a trigger event is that we looked at, I believe it was properties, and when we looked at the event notification, we created an event notification that of anything that is put in post in the folders raw with the JSON tag to be pushed to the SQS queue. And we made an SQS queue called S3 to RDS. In our R3 to, this is just a simple message queue. We set up a dead letter queue, and this is going to be the trigger for our next Lambda function. Next, we're looking at another Lambda function that I called SQS RDS. This basically takes that SQS message as a trigger and pushes data into the RDS that we've configured. This one was built using layers, and the reason why I had to use layers in here is because I'm using PyMySQL to help input data into my RDS function. This is a little bit of a complex script because I was having some trouble with reading SQS messages and trying to get the exact bucket match and key match. Initially, when I was loading the JSONs, it was giving me a lot of errors. So I wanted to make sure that, I can at least get the bucket and key match through regex, but still kept all the other methods in here. So this script is a little bit complicated in that case, but essentially what we're doing is we're taking the bucket files and loading them, loading the JSONs, and then connecting to our RDS through PyMySQL, and then uploading the files that way. And we have two functions, load stock dimensions and load stock fact. Both of these are meant to automate the load of each data as we parse the JSON, and this also takes care of removing any duplicate rows that we have. So I'll show you the layers piece. So we created a layer that can be used later because we will need this PyMySQL layer for the query Lambda function as well. So by building this one layer, we're able to add it to other Lambda functions in the same availability zone without having to re-upload like the previous steps that we did before. And So I can run a quick test. So if I run a records, this is basically duplicating a record, um, a record from a message queue, and it's processed one of the files. It's connected to RDS, successfully connected, fetching the Amazon JSON file, and then we are loaded the stock dimension and loaded the stock fact. So we've processed the batch. This is basically our test. Next, I'll show you the RDS configurations and how that looks. Yes, with the MariaDB engine. In this case, we created a RDS that is publicly accessible. The reason why I did this was because this allowed me to debug a little bit easier and during development. So I could connect to something like my DB Beaver. As you can see here, we have our database Fang DB. We have all of our tables, and we can look at basically any of our users that we've created. We created one query API, and we create this is the admin. This is the admin user. This way I can monitor if things are being added correctly, just at least in the initial phases. Again, the traffic for this RDS is configured through security groups. So so although it is publicly accessible, only Lambda instances or any ARN instances that are tied to this security group can access this RDS. Otherwise, it's blocked. Yeah, and so that's the RDS. And that more or less concludes our ETL process. So as a recap, we have two lambda functions, one that extracts data and one that loads data, and that's all controlled through an SQS with an S3 event notification. Next, I'll be showing you the API gateways and the Lambda function that processes all the API requests. So we've reviewed all of the ETL frameworks, and now it's time to look at the Amazon Gateway API gateway and Lambda functions resulting in those, and our wrapped endpoints and Python SDK. So unlike the Lambda functions here, which is one directional, in this case, this Lambda function is taking a trigger from an API gateway and then querying data from the RDS MariaDB and then returning data back to the client. So next we'll look at that Lambda function. So in this Lambda function, this is called Fang query function. There's one trigger, it's the API gateway that we just saw. And this function is fairly simple as well. It is just, we built it with the same layer as the PyMySQL layer. It takes the request coming in and then parses it for our RDS to see if it's a CSV or a JSON, and returns that data to the client. So nothing too different here. I think we have the same configurations as the other Lambda function, so I will kind of skip over this and get into the API gateway. In our API gateway, we have one valid method, and that's a get method. So in our get method, we basically have a URL query parameter of an end date, format, start date, and stock. We don't require a format because the standard format that we've made this endpoint is JSON, unless otherwise specified, and we pass that on to our Lambda function through the same things: method request, query string, so on and so forth. We did add a couple of things to this. So first of all, This method is binded by an API key. And how we created the API key was we created an API key that's called test user, and we tied this to a usage plan. This usage plan is then is 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 then tied to an associated stage called stocks data API. These are all the APIs that's been associated with, and we, you know, tied it to this. So that way we can kind of control how much people query our data, much like how we have an API key for 12 key. We have created one so that anybody else with an API key can access our Lambda function through that. Um, and, and last but not least, you can see where our API gateway URL is. So you can come here to query our data as long as you have an API key. And so in the next stage, we'll go on to demonstrate how do we access these 2 points. One is through Postman. The reason why we're using Postman is because we do need an API key to push this through, and through browsers we can't really add the headers. So I'll show you through Postman, and then the other method is how do we build a Python package SDK to query this data. So first, the simple method is I already ran some queries here, but essentially, I have this query endpoint along with our start date, end date stocks, and I'm asking for a CSV format, and when I send, it should be giving me that CSV format. So this is the data that we will be getting. And you can imagine if this was a browser, it would download into a CSV file. Or if we had a more front end, it can kind of display this however we would like to show it. The second piece is, we mentioned earlier that we wanted to be able to allow other users with different needs, such as data scientists, to integrate within their workflow. So this next demonstration is through a Python SDK. So I set up this Fang SDK as a Python SDK to access the Fangstock API. So we only need requests for this package, and it is a fairly simple package. It just has one object called API client that has a few methods called querying stocks, and then it takes in an API key. But the great thing about this is that instead of having somebody write out all the different request headers, they can just install our SDK, and you can imagine this flow within a data science notebook. This is a IPython notebook. So when we run this, we can show you exactly how easy it is to just query our data. So we entered our data as attributes. We created an instance of a API client with the API key integrated, and then we just queried the data. And through this, we're able to see that this is returning all of our data. And you can easily convert this into maybe a data frame. You can convert this into other types of tensors or what have you, to integrate better with other work streams. And that concludes my presentation for the serverless data mart. I would like to thank Professor Misiko and all the TAs. I had a lot of fun learning with this class, and I hope to continue building afterwards. Thank you.